Hello all, myself Professor A.J.More, working as Assistant Professor in Engineering Sciences Department in All India Sri Shivaji Memorial Society, Institute of Information Technology, Pune. My today's topic is Basics of Engineering Drawing, Part 4, the sum of the dimensioning rules. In the previous lecture, we have seen some of the dimensional uh, rules with respect to the types of lines and the systems of the dimension. Again, in this lecture, we are going to consider the dimension rules in the expressive way. So, the to get the good marks or to show the diagram appropriate, uh, aesthetically good. So, we are going to there should be a good systems of the dimensioning, and you should show the dimensions correct way. Otherwise, there is a chances of getting less mark or to lose your own marks. So in every paper for your 50 marks paper, there are you have to attempt four questions. Out of the four questions, almost 10 marks are for the dimensionings and the rule. Out of this, in this case, if you understand the correct way of the dimensioning, those 10 marks are of you. So in the dimensioning, we learned in the previous lecture. So what is dimensioning? Dimensioning is a numerical value expressed in the appropriate unit of measurement and indicated graphically on technical drawing with lines, symbols, and notes. Unit for the measurement in both the cases, maybe the technical drawing in case of civil or architectural drawing, or the mechanical drawings, we are going to use all dimensions are in mm. So angles we are going to show obviously in degree, the symbols incorporated to indicate specific geometry wherever necessary, and notes are provided to give specific of particular features, maybe flatness, perpendicular surface, parallelity, or maybe the number of quantities and material, etc., on the particular drawing. The specific information necessary during the manufacture of the object. So this you have learned in the previous case. So this is a drawing sheet in which this you can see particularly uh, the you can say uh, the drawing. This is the drawing space. This you can use the drawing space, and all the dimensions you are going to show in the mm. In the next lecture, in the next slot, if we go ahead, so um, dimensioning. So we are providing, if you see this diagram, in this case, the the location dimensions are shown. The location dimension for this rectangle with the circle is expressed with the this corner to this corner with the means the corner, the location of the dimension shows the line of the symmetry of the circle with the corner. This indicates the location of the dimension. Location of the dimension. And for this case also, this dimension is from this corner to the center of this line, which indicates the location of these dimensions. This whole is expressed by using this whole is expressed by using the leader line. So this is nothing but your leader line. Okay. And this is the size dimension, the width of the particular rectangular block. Length and width are nothing but your size of the dimension. And this whole is indicated by 5. 5 is the diameter, already we have covered in the previous lecture. And the size of the hole is 15. 15 is nothing but diameter of the hole is 15 mm. Okay, this is the size dimension and the detailed features of the manufacturer. These indicate if you want to produce such kind of surface with respect by using the machine. So roughness of that particular machine or roughness of that particular surface is should be 0.5. So it can be shown by using the leader line again. Okay, so this we can use by using the dimensions. previous case we have learned this. Again, if we go ahead, so different lines of dimensioning, outline, extension line. This we have seen by using the example in the previous previous diagram. So this is if I ask you to which kind of uh, drawing is this and which type of line, this is the outline of the object, thick line. So 0.5 mm thickness you can use by using H pencil. The next, if I go ahead, so this is outline. Then if I ask those vertical lines, vertical lines vertical lines we can show by saying, suppose this is vertical line and again this is vertical line from the edge of the diagram. This is the extension line. If I go ahead with this again, if I go ahead, so this is extension line. Again, this line is indicated by using the dimension line, and the 50 is nothing but dimension value. Now if we go ahead, again the this roughness shown by the leader line. You can show the material as a note, which kind of material, MS material, or aluminum, copper, or whatever. So this indicates the type of the lines of with the diagrams. Next, if we go ahead, rules for the leader line. So what is the rule? Basic rule for the leader line to show the you can say the arc of the radius, to show the whole of the uh, diameter or the radius of the hole, or the roughness, or the to show the any node of the measurement, number of quantity, material, etc. You can use the leader line. You can see this leader line is shown here. So how I can show? It can be drawn not less than 30-degree angle. You can use the standard angle 30-degree or 45-degree with respect to the base or with respect to the horizontal lines. And you can show the dimension or the node of the particular feature. Then arrowhead. Again, the arrowhead is most important, showing the arrow to the diagram. In other subject, you might be using the this kind of arrows, this kind of arrows in the other subject. You might have used this, you might have used this, you might have used this. But what is the correct way of showing the arrow to the any feature? The correct way of the showing dimensions is your arrow should be 3:1. So what is the size of arrow? Proportionate length. Your head. This is called the head of the. This is called head of the arrow, and this is called the spread. This arrow head to spread. This should be 3:1. It should be 3:1. So that is, it can be shown by using the extension line, and the proportionate approximately your arrow should be such this. It is a closer and filled, closer and filled. So as per the 3:1 ratio, approximately 3 mm spread and 1 mm, the head of the arrow should be there while showing the arrow. This is most important feature of the diagram. Okay. Next, if we go ahead, uh, the dimension elements. So as you've seen, this is the particular dimension. So if I ask to give the dimension using the whatever we've seen in the diagram, if I show, so you can see the whatever the types of lines and the way of dimensioning are shown, the how to show the angles, how to show the dimension. So this is the location. 50 is indicating location of the circle. Center to center distance between these dimension is a location dimension. So two holes of 520. How many number of holes are mentioned? And that is the quantity. And the 5 is indicate diameter of this circle. Again, these 40 indicate the size of the dimension. That is the size dimension. Okay. Then the angular dimension, the angle of between the notch. So such kind of features you have to use in the actual drawing, and this is most important to show the dimension, to show the features on the diagram when we cover the actual physics. Then the placing the dimensions, as we have seen the systems of dimensions, the uh, aligned system dimension and unidirectional system dimension. Both can be used, but the correct way of dimensioning, you should show the dimension in between the dimension line and perpendicular to dimension, or in between the dimension line. So that is the correct way with the of the dimensioner. This is incorrect way, and how to show the angle between the two lines, two surfaces or two parts. This is the way of the correct way of the dimensions. Again, if I go ahead, so there are various types of the dimensions. The one is the chain dimensioning. So if you see, all dimensions are aligned in such a way that arrowhead of the dimension such that tip to tip arrowhead on the adjacent dimension, and the overall dimension is placed in outside the other smaller dimension. So always show the smaller dimensions inside and the larger dimension outside the view, and there should be a spacing between the maximum 10 to 15 mm between the two dimensions lines. So these are 12, 8, 15. All dimensions are placed in series with each other. That is a chain or the continuous type of dimensions. Then next, if I go, the that is the parallel or the progressive dimension. All dimensions are placed commence from the reference line. This is the reference line, and with this reference line, you can see this is my reference line. From this reference line, the dimensions are progressively increased, and all dimensions are placed parallel to each other. So this is the way of the parallel dimension. Then, if we go ahead, the combined dimension. This is the combined way of the chain and parallel dimensions. So one dimension, two dimensions are placed in a series with each other, and other two dimension 8 and 20 or 8 and 15 are in parallel with each other. That is a combined type of dimension. When both the methods, the chain and parallel dimensions are used, the same drawing, the method of dimension is called chain or combined dimension. So how to show the correct circular hole? So you cannot show the picture shows the correct way of the showing the dimensions. So 540, 520, 515, all are the holes all are shown by using the phi. If the radius or arc is there, then we have to show by using arc. If the whole circle is there, then we can show by using the diameter. So holes is usually dimensioned by giving the diameter instead of radius, and it is symbol is used, phi symbol is used. Then if the concentric circles are there, how to show such kind of parts? So this is the tapered part is there, not tapered, I can say the concentric part, or you can just tape the shaft is there, and how to show that particular hollow shaped shaft. The 520, 530, 540, all the circular holes, that is hollow shaped shaft, are shown by using such kind of dimension. That is the correct way of dimensioning, and this you can show in this case, this is nothing but your cutting plane. This is nothing but your cutting plane. If I cut this particular shape, the shaft, hollow shape the shaft, you can see this is the way the cutting plane can be shown, and this is the way of showing the hatching lines. Hatching lines are always parallel to each other, and distance between the hatching lines are 1 to 3 mm, and they are always inclined with the baseline at a 45 degree. Okay, again, this is a chain and parallel combined dimensioning with the aligned system dimensioning system is used. Okay, now if we go ahead again, number of holes. Every time over dimensioning is not allowed. Over dimensioning is not allowed in the case of over dimensioning is not allowed in case of any drawing. So if the same features are available in the drawing, so you can show like this: 3 holes, 520. As so all the dimensions are of the same size of the hole, so the number of quantity and the same size, that is a 520, you can make. But over dimensioning is not allowed, or that is not correct way of dimensioning. Then if we go ahead, how to show the arc for the particular chamfer fillet. So the arc usually dimension by giving its radius, that is the R. R indicates the particular dimension placed inside the value or outside the that particular feature. So the both the way is applicable in case of the time, but the plus indicates that the center of that particular feature. Then how to show the actual way. In shop floor, we need to supply both the 2D drawings as well as 3D drawings so that the shop floor person can understand what they are going to manufacture. So to understand the clearly object view or object dimension, overall dimension, so we should provide a 2D dimension as well as 3D dimension. So in that way, the correct way of dimension. In this way, we are going to show the dimensions in the shop floor with the maybe number of quantity, material required, and other manufacturing considerations we are going to show on the diagram. Spherical, if the special feature like sphere is, if you are going to show the spherical feature, you are going to use the symbol SR or S5 to proceed with the dimension. So you can see the way spheres are used, the SQ or SR are used for the to show the spherical feature. Then to show the dimension for the square, you need not require to show the dimension for all the sides. So you can use by using the square. So you can see you can use by using the square. So this is the square. Then SQ you can use or this feature. But I think correct way to show the dimension for the square is this way. So if we show this dimension, that is not correct way of dimension, but it is applicable for the whatever we see. Then if we go ahead, some rules are there for the dimensioning. So taper are always measure if the taper surface is there for the flat surface, we have to show that slope in terms of 1:4 or in this kind of features we have to show for the taper. So this most of the time it is not for our syllabus. Then dimension for the thread, if such kind of feature is shown, so what it indicates, the M indicates the your internal threads, metric threads. The external metric threads are dimensioned by giving the thread length, nominal diameter, which is by symbol M. So M12 means the diameter of that particular thread, that is the original diameter or nominal diameter. Internal threads are dimensioned, threaded length, depth are drilled hole before threading and nominal diameter preceded by symbol M. Again, the same thing is there. So if M is there, then it will be the internal threads or it is the nominal diameter of the particular threaded hole. So the general rules, whatever we see, so those rules are there. So I'll read out those general rules for the dimension which are most important. The between any two dimension lines, there must be one and only one dimension linear bearing to one dimension. One of the extension line may be common to another dimension as in parallel dimension. So we have covered all this. So as far as possible, all the dimensions should be placed outside this view. Except the radius, all dimensions should be the outside the views. So there should not be too close to the your feature or the your diagram. All dimensions on the drawing must be shown either by aligned system or a unidirectional system. Both the dimensions are applicable. Systems are applicable. Same unit length should be used for the all the dimension on the drawing. So inch and feet are the inch and the millimeter. It is not used. You have to use the all dimension in mm. That is the metric system we are going to use. The dimension lines should not cross each other. So two dimensions should not cross each other. Separately, we have to show the entity's dimension. The dimension line should not cross any other line of the object. All dimensions must be given, and over dimensioning is also not allowed. Each dimension should be given only one. That is the over dimensioning is not allowed. This is the homework for you. On the left hand side, I have shown some wrong dimensioning techniques, and on the right hand side, I have shown the correct way of the dimensioning for this particular diagram. So go through this. Some abbreviations for the what is exactly the features, which symbols you can use for the which symbols you can use to show the dimensions for different entities. So it is shown. Thank you. So in this lecture, we have covered the dimension rules with respect to the types of lines. Thank you. In the next lecture, we are going to start the another topic that may be the DLS, development of level.